Professor Kent Marshall, Professor of Chemistry, and his lecture is entitled Teaching Sophomore Organic Chemistry and Doing Synthetic Organic Research at QU.
Let me get my stuff up. I'm not a math person. Oh, cool. Okay. Okay, welcome. My topic is a little drab compared to the others I see because I was told I had to talk about something I do at Quinnipiac. Not that I had open rem to do anything. So what I do, I'm Dr. Marshall at Quinnipiac University, Department of Chemistry. I'm going to talk about teaching what I do is teaching sophomore organic chemistry at Quinnipiac and do synthetic research. That's going to be my game. So we start ourselves off. I've been here, Stan beat me, I've been here for 40 years. When I came here, it was known as Camp Quinnipiac. Quinnipiac College, in the case. I was going to talk about what was here, 4 buildings, stuff like that. I'll go on past that, in the case. Now, so what happened? I'm primarily involved in teaching sophomore organic chemistry. It's taught and taken by sophomores, theoretically, juniors and seniors. Right? The course is a standard 1-year full course involved for chem majors, biochem majors, biology majors, bioscience majors, the physician's assistant majors, psychobiology majors. It has, unfortunately, a terrible national reputation of being the pre-med cut course. And Dr. Smith and I go out of our way to show it does not need to be that way, but it turns out it is. Right? So what is organic chemistry? It's the beast is there. All right, so what is it? Organic chemistry is the study of carbon compounds. Right? Now, they're grouped by families of what we call functional groups. Now, functional groups are a group of atoms that have specific chemical and physical properties. They can be as simple as the hydrocarbons, the alkanes, alkenes, alkynes, if we want the arenes. Many of them contain heteroatoms. Oxygen, nitrogen, and sulfur are the most common. So under the oxygen category, you could have the alcohols, aldehydes, amines, carboxylic acids, esters. The nitrogen compounds will be the amines themselves, the nitriles, amides type thing. Sulfur compounds is the skunk goodies, or the thiols and the sulfide. You can also have halogens in the compounds. Many natural occurring compounds have halogens in it, and that's going to be either chlorine, bromine, or iodine, and they're called the alkyl halides. So what do we do in the course? Our goal is we're going to start off, do a little bit of stereochemistry to study the three-dimensional relationship of the molecules. We'll do a lot of nomenclature. People hate nomenclature. How to name these things by the systematic nomenclature and some common. We'll do the synthesis of these functional groups. We'll look at some of the reactions, in fact, many of the reactions in the case. We'll also look at how these reactions take place, which will be called the reaction mechanism. In the case. That is probably one of the hardest things the students have to work with. Right now we're actually working on the spectroscopy part where we'll use nuclear magnetic resonance, infrared spectroscopy to study structure work in any case. That's that part. Now next part, I finish up where I'm a synthetic organic chemist and my job is to make larger organic molecules from smaller ones. In the case. Now I've been now doing it for 40 years, I've geared my research around projects that the chem department majors have to do for their senior project. Their required on-hands project in the case. And this molecule I'm showing here, which is known as an amide. So if you look at this part here is amide. Now this was originally designed and discovered by the heating of capsaicin. If you look at capsaicin, take this thing and squiggle this off and just put a hydrogen right there. That was called capsaicin. What we're trying to do is, it was discovered in what they call a pyrolysis, a heating experiment, in a sub-microgram quantity, very small quantity. What we're trying to do is to then synthesize an authentic sample so we can verify that yes, the structure was made in the case. So this project has been going on for quite a few years, working with undergraduates, very difficult. They don't have the time commitment, they're learning all that magic stuff in the case. So I've been working on this thing since 1992 with a 7-year gap in the middle where I didn't have a lab in the case. We're almost, with the student I have now, if everything goes right, we're going to finish it this year. So I thank you so much.